Let us now take the case when the Mohr circle becomes a point. When we say that Mohr circle is a point, it means there is no shear stress, because shear stress is coming due to the radius of the circle, and shear stress is equal to tau max is equal to radius of the circle. And if there is no radius of the circle, there is no shear stress developed. So let us say there is stress element. This is our stress element, sigma x, sigma y, and sigma x is equal to sigma y. Both are equal in magnitude as well as direction. Both are tensile or compressive, and both are in equal magnitude, right? And we want to draw the Mohr circle for this stress condition. So let us draw Mohr circle for this stress condition. On this axis we are taking the normal stresses, and on this axis we are taking the tangential stresses, right? And here it is O. So what will be the center? What will be the center of this circle? Center. So what is center? Center is sigma x plus sigma y by 2, 0. Here the sigma x and sigma y are equal. So let us say this is sigma. So you will get sigma x plus sigma y as sigma by 2. 2 sigma by 2, you will get only sigma. So center will become sigma and 0. So this is our center, sigma and 0, point C. And what is radius? What will be the radius? That is equal to, what is radius? That is equal to under the root sigma x minus sigma y by 2 whole square plus tau square. And sigma x is equal to sigma y. So this will become vanish. And there is no shear stress applied. We are not applying any shear stress. So tau is 0. So it means radius is 0. And when there is no radius, it means our Mohr circle is a center. So in this case, when there is radius is 0, as radius is 0, so there is only point obtained. So we have obtained only a point because there is no radius. Radius is 0. So when we are obtaining only a point, so there is no length in the vertical direction, and there is shear stress in vertical direction. Horizontal direction, in this linear direction, we are getting certain distance, and this distance is basically sigma x, which is equal to sigma y. But in vertical direction there is no distance. So at any stress element, we will get the same value of sigma x and sigma y. At any stress element we will getting the same value of sigma x and sigma y, and tau will be equal to 0. So at any oblique section, the stresses will be only normal stresses equal to sigma x equal to sigma y, and there is no shear stress. No shear stress means tau will be equal to 0. Tau will be equal to 0, or sigma t will be equal to 0. We are using sigma t. So sigma t will be equal to 0 at any plane. किसी भी plane में, at any plane, we will get the sigma t will be equal to 0. So here if we show the stress condition if we show the stress condition on this angle, we will get only these stresses, normal stresses, sigma n, which is equal to sigma x or sigma y, sigma n equal to sigma x, and also this stress condition, this is sigma n again equal to suppose sigma y, and there is no shear stress on this element. So this is the another special case of Mohr circle in which we are getting the Mohr circle as a point. When the stresses applied stresses are equal in magnitude as well as direction. Either they are tensile or compressive, and the magnitude of both the stresses are same. Sigma x and sigma y are same here.